Hello, my name is Kyle Nguyen, and this is my tutorial on how to pick parts for electrical for robo wrestling. So we're going to pick some parts out now. We're not going to pick out all of them, but we're just going to get started. Some of these include the motors, the distance sensors, line sensors, microcontroller, and the battery. So you could pick these in any order except for the battery. You should be picking your battery out last. And a decent website to find your parts on is just jsumo.com. We can check it out real quick. These have a lot of parts for our purposes for robo wrestling and a lot of robo sumo stuff. As you can see, they have stuff like silicone wheels, motors. They have like whole robot like do-it-yourself kind of thing, but we are not going to build this like this one. We are not buying a kit. We are building it ourselves. So yeah, just keep that in mind. Oh shoot. Alright, first up we have the motors, and these are going to turn your wheels. I don't really have any common recommendations, but just some advice. Pay attention to voltage. 6 volts or 12 volts should be good. But your battery selection is going to depend on this later, so just pay attention to the voltage rating. Make sure your motors fit. So for the mini sumo competition, the length constraint is 10 centimeters. So I can show you. We're going to just go to motors. We're going to pick a random one. Let's say this one. Okay, so this one, we can look at the specs. Motor dimensions 32 by 32 by 90. We can already see that this 90 is, if you translate that to centimeters, it's just 9.05 centimeters, and our max length is like 10 centimeters. So this is already not going to cut it. We're probably going to need something less than 50 millimeters. Because we have 2 motors. If you want to go over 50 millimeters, you'd have to check with your mechanical person, but I would not recommend it personally. And another thing to pay attention to is the price. We are not sleeping on bags of money every night. Please do not financially kill us. Next, we have distance sensors, and these are just sensors that detect the position of the opponent robot. We have 2 types of distance sensors. Number 1, we have digital sensors, and these return a binary value depending on if it sees something or not. For example, it's going to return a 1 if the sensor sees something, and a 0 if it doesn't. The second type we have is analog sensors, and these return a value that represents how far away the opponent is detected. So it's not constricted to having a value of 0 or 1. It could be 0, it could be 50, it could be 900, and these values are just representations of how far away the opponent robot is, or how far away the thing is detected. And just a common recommendation, I would just go for the JS40F infrared digital distance sensor. It's very small, very easy to work with, and it's cheap. So I think most people use this when I was doing my mini sumo project. So I think this is a pretty solid choice. And some advice, use digital because it's faster. Pay attention to price. These are pretty cheap, so if you pick this one, you're good. Make sure it's not too big. Again, you want it to fit within the size constraints. Alright, next up we have line sensors, and these sensors are pointed at the ground. So the arena that we compete in is a circle, kind of like a Japanese sumo wrestling circle, and the outer ring is white. So this sensor points down and basically detects if the robot is at the edge of the doyo. So if it, this is an example, but if it sees white, it might return 0, and if it sees black or anything else, it might return a 1. You could also set these to analog values, depending on what line sensor you get. I think analog is recommended, but digital is okay. But analog is probably recommended. So for these, we recommend the micro line sensor ML1. You could also go for ML2, but those have very gimmicky shipping issues because we tried ordering some last year and they did not come, so we had to get a bunch of just ML1s. But if you want ML2, you could also go for that. And some advice, use digital, shoot. Use analog. That completely contradicts what I said. Use analog and pay attention to price. Alright, next up we have the microcontroller, and this is just a compact integrated circuit designed to govern a specific operation in an embedded system. You can kind of think about this as like a mini computer, and you could plug it in with a USB, put some code onto it, and it will do certain things for you. Our recommendation is to get the TZ 4.1. It's maybe like $30. It's very small and it works pretty well. I would just say please get it and not another type of microcontroller so that we can help you best. Alright, now we are going to move on to power budgeting and batteries. So, power is just a measure of electrical energy per unit time. So the formula for that is P equals I times V. So power equals current times voltage. Your power budget is basically telling you how much power does your circuit draw. And this needs to be within your battery specs. So the first step of doing power budgeting is to determine the max voltage of each device as well as the peak and the nominal current draws. You can find this information on datasheets or the website. The second step is to calculate maximum power for each device using our equation right here. And our third step is to find the total max power draw for the robot. So you just add all the powers of each device. So that might seem like a lot if you're not experienced in this, but I made a cool little guide that might help you. I just clicked on this link down here. So yeah, I just made a little sheets here. Basically, you just fill out the information inside the boxes, and it will calculate all the stuff that you need. And the things that we're going for is total nominal power, total peak power, and the peak current. So we're gonna get started. I'm just gonna be using the parts that I used for my old bot last year, and we're just gonna start with the motors. I used these motors. They're kind of mid. One of them actually broke like maybe a week before my in-house competition, and that was not fun to find a replacement. It's very stressful. Anyways, we're gonna be looking at how many we're getting. So we're probably gonna want 2 motors. Just put 2 in each of these. Next, we want the nominal current. That's just the normal or idle. So this is 50 milliamps. All right, 50. And the peak current is 850, which is the stall current. So we're just gonna put that in as well, 850. And what voltage do these run at? These run at 6 volts. And it says it's over voltageable up to 12 volts. When you overvolt your motors, they will run faster, but at the same time, they will burn out faster. So if you do decide to overvolt them, make sure it's not like for too long, because you will actually destroy your motor if you run it for too long. But these are at 6 volts. So I put that information in, and these values up over here update. Next up, we have the microcontroller. I'm going to use the TNC 4.1. This is pretty much what everyone should do. but we're going to look for number, or just one current. When running at TNC consumes approximately 100 milliamps of current. Okay, that is 100. Notice that this does not have a peak. It's just the same current for nominal. And you can just trust me on this. This is the voltage it's gonna be run at is 5. If you look at the datasheet somewhere, it will tell you 5. But you can just trust me on that because I've worked with it before. All right, next up we have the JS40F. My robot used 4. We had one facing forward, one facing left, one facing right, and one facing back. You're probably going to be wanting to talk to your mechanical and your computer science members about this. They'll probably want a certain amount. So my team decided 4. We're just going to 4 in here. We're going to see how much current these draw. We scroll down. And works between 3.3 volts to 5 volts. At 5 volts, sensor draws 15 milliamps. So we're going to do 15. And for voltage, let's see. It works at either 3.3 or 5. Now, we could put 5 here. Putting 5 here would not be wrong. But I actually connected my sensors to 3.3 volts. So I'm going to do 3.3 instead of 5. Alright, next up we have the line sensor. It's right here. This one also works at 3.3 volts, and we want 2 of them. My robot had 2 in the, or no, not 2. 1 on the left side of the front and 1 on the right side of the front. Yeah. So we're gonna put 2 because that's how many we have. Current is actually not on this page. So the bad thing about JSumo is the lack of data sheets, and it's pretty unfortunate, but you could trust me. Just trust me. It's 15. Okay. And I did run these at 3.3, so we're just going to put that information in. Okay, so basically what this does is it goes across and it just multiplies everything. So 2 times 50 times 6 is 600. 2 times 850 times 6 is 10,200, etc. And for total nominal power, it takes all these nominal power cells and it just adds them up. Total peak power, it takes all the peak power cells and then adds them up. And for peak current, it just takes the peak currents of all these parts and it just adds them up. No, it takes the peak currents, multiplies it by the number, and then adds it up. Yeah. And if you want to learn more about which cells I use, you can click on this. You can look up here. It's pretty simple. But yeah. Alright, next up we have batteries. This is the last part that you should pick. LiPo means lithium polymer battery. There are 3 important specs that come with a battery. The first one is the cell count, which is represented with the S. Multiple cells are connected in series. So the nominal voltage is equal to the cell count times 3.7 volts. So if you have a 3S battery, you just take 3, you multiply it by 3.7, and then you get 11.7. The second spec that we need to pay attention to is the capacity, and this is measured in milliamp hours. And this is basically just how much juice is in the battery. You can calculate this by doing milliamp hours equals the current times the time. Like you see the milliamps and then hours, so it's just current times time. Here's an example. If it's 1000 milliamp hours, that means that it can output 500 milliamps for 2 hours. You just multiply the 500 by the 2 and you get the 1000. The last spec that we want to pay attention to is the discharge rate, and this is just the peak current supplied by the battery. So we can calculate this by doing peak current equals capacity times the discharge rating. So if our battery is 1200 milliamp hours and it has a discharge rating of 75C, then we just multiply it together and you get like 90,000 milliamps, or that's just 90 amps. Okay, so your final step is to choose a battery. So the first thing you want to consider is the highest voltage that you need, and this is going to determine the number of cells in your battery. So your motors will probably have the highest voltage, so you want to make sure that your battery voltage is higher than your motor voltage. Some motors are over voltageable over a short time, so you could probably pick a battery with a higher voltage than your motors, just a little bit. And we would recommend the 3S LiPo, which is 11.1 volts with XT60 JST connectors. Now I can show you what these look like. XT60. So it's these yellow things. These are good because you can just stick them into your PCB, you solder it, and it provides an easy way for you to plug in and unplug your battery from your PCB. The second thing you want to consider is you want to check if your peak current of the battery is greater than the peak current of your circuit. And you can use the equation from the previous slide. Peak current equals capacity times the discharge rating. And the last thing you want to consider is how long will your battery last. So you can use this equation. The time your the time your robot will run is equal to the capacity measured in milliamp hours divided by the peak current of your circuit. And you want to make sure it runs for a while, and just for reference, each match is going to last about 15 seconds. Alright, so let's open MS Paint. Let's go back here, move this over here. Alright, so I'm going to show you how I might choose a battery. So I think the first thing I did, I picked a battery with a good voltage. This one is 11.1 volts. Our motors were 6 volts, and those were the highest thing on there. So let me just write down the specs of this battery first. It's a 450 milliamp hours, 25C. This was 3S. And this was 11.1 volts. So the first thing you want to consider is the battery voltage greater than the voltage of the highest voltage component in your system. So we have 11.1 volts, and our highest voltage component is 6 volts. So 11 is higher than 6, so this is good. Alright, next. We want to check if the peak current of the battery is greater than the peak current of the circuit. So to do this, we have the equation peak current equals capacity times the discharge rating. So what we do here, we take the capacity, 25, and we multiply it by the discharge rating, 450, and this is just equal to 11,250, I believe. So we have 11,250, and this is milliamps, and our peak current, if we look on the sheet, was 1890. And we can see that 11,250 is greater than 1890, so we are good here. And the last thing we want to consider is let's see, how long will my battery last? So we can take our capacity, so that is 450 milliamp hours, and we divide it by the peak current of the circuit, which is just 1890, and this is just equal to 14.29 minutes. This number right here is going to give you like 0 point something. I just multiplied by 60 to convert it to minutes. And 14.9 minutes is way more than 15 seconds, so we are good. I think you don't want a battery that will only last you like 30 seconds, 1 minute. You probably want to go higher so that you can test it without risking your battery dying on you. And just to keep in mind, these batteries are rechargeable, so that is a thing. Alright. So, that's all I have for you. I stole a lot of information from this presentation. You can go to the link here if you didn't understand anything that I said. This is from my electrical lead last year, so be sure to check it out. And yeah, that's all I have. So if you enjoyed this video, make sure you like and subscribe, and you can check out my other videos as well. So yeah, thank you for watching, and good luck on your part picking.